Hello class, today is the week of April 27th and this will be our first lesson for the week. This week you're going to have 2 lessons and a major grade. Okay, and this lesson is going to be the introduction to polynomials. Okay, so let's get into this. Okay, so first thing, I've got a joke for you. It says, "Hey Joby, what do you call a bird that doesn't eat?" Well, I don't know. A polynomial. Get it? Poly, bird, no meal, because they don't eat, no meal. Ha 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 ha. It's always a good way to start off a lesson with a joke. Okay, so let's get into this. Okay, so today we're going to be learning how to classify polynomials by degree and by the number of terms. Okay, so there's several definitions that we're going to be looking at today. Monomial, polynomial, binomial, trinomial, and then the degree of a polynomial. So that's the information that we're going to be looking at today. And really when you look at it, monomial, binomial, trinomial are all different types of polynomials. And that's what you're going to find out in this lesson today. So it says, the simplest type of polynomial is called a monomial. A monomial is a number or a product of numbers and variables with exponents that are whole numbers. Okay, so inside this, there's several things that we have to understand. Okay, so a monomial is a single term. Okay, there will be no plus or minus. Okay, it's going to be the product, which means we're going to be multiplying. So that means we'll have numbers and letters that are shoved together. Okay, and because anytime we know that a number and a letter is put together, we know that means to multiply. So we will have the product of numbers and variables, which are our letters, with exponents that are whole numbers. So if they have an exponent on it, the exponent must be a whole number. Okay, so here's some examples of monomials. 2n is a monomial. You have a number and you have a letter shoved together for multiply. You have x to the third power. Okay, so that's perfectly fine. Okay, this exponent here, the big thing is it must be a whole number. Okay, this one right here is kind of the one that we have to get used to. This entire thing right here is a monomial. It's the product of 3 things. It's a product of a whole number, a letter raised to the 4th power, and a different letter raised to the 3rd power. Okay, so it's the product of numbers and letters, and each of the exponents are whole numbers, so it's perfectly fine. Now, this 7, it is a monomial. Okay, so it is just it's not a product of anything, but it's just a whole number, and that's perfectly fine. So it says a monomial is a number, okay, or the product of numbers and variables. So it can either be just a single number, or we can have things multiplied together. Now here are some examples that are not monomials. So if you'll notice right here, here's a variable raised to an exponent of 2.4. So this exponent right here is the problem. Okay, it must be a whole number. Okay, now this next one, 2 to the x power. Now you may think, oh, that's no big deal. But remember, this x can be anything. So it could be a negative number, it could be a fraction, it could be a decimal, it could be anything. Okay, so this one is not a monomial. Okay, now this square root of x. Now, when we put this one in there, this x underneath a radical, okay, that means this x could be anything. So it could be a negative number. And as we've talked with negative 1s underneath a radical, that is not okay. That's kind of the definition of an imaginary number. So if you have a radical, which is okay, you have to have a monomial underneath it, just a regular number, but no variables. Okay, you can't have variables because we can't determine what that variable will be and what it would do to the value of the thing that's inside the radical. And then for the last one, you also cannot have an exponent or a variable in the denominator of a fraction, because that variable could very easily be 0, and we know 0 division by 0 is undefined. So the instances that it would make it not a polynomial or not even a monomial is if you have a exponent that is something other than a whole number, if you have an exponent that's a variable, if you have a variable underneath a radical, or if you have a variable in the denominator. Those are instances that will make it not a monomial. Okay? So let's see if you can determine if things are monomials or not. We're going to do 2 together, and then I'll have you do 2 by yourself. Okay, so this one, it says, determine whether each expression is a monomial. Again, if we look back at that definition, it's the product of, or it's a number or the product of numbers and variables. As long as the exponent is a whole number, then we're good. Okay, so A. Okay, would this be a monomial? Well, if you look at the number inside the radical, it is a whole number, so it's perfectly fine. Each of the exponents on my variables are whole numbers, so this one, yes, it is a monomial. Okay. If we look at this one over here, the 3 and the x to the third power are perfectly fine, but having this variable underneath a radical makes it not a monomial. So this one is, the first one is a yes, the second one is a no. Okay, so what I'd like for you to do is pause the video and tell me, is A or B, or A and B, or either one of those, or both of those, are they monomials? Okay, so let's see how you did. So on A, you've got 2 times w, and if the w doesn't have anything on it, then we know that there is a 1 as an exponent, so that's a whole number, times p to the third y to the 8th. So another way of writing this would be just 2wp to the third y to the 8th, and it would be perfectly fine. And yes, this one is a monomial. Now B, if you looked at this one right here, if you'll notice right here, this 3.2 is an exponent, that automatically makes it no, this is not a monomial. Okay, so hopefully you understand how to determine whether or not it's a monomial or not. Okay, so that was one of our first definitions that we had to understand. Okay, so now we're going to look at the next 3 things. Okay, so let's look at those definitions. It says a polynomial is one monomial or the sum or difference of monomials. Okay, so a polynomial is a collection of monomials put together by either plus or minus. Okay, so if it's a single term, we know that it's a monomial. But polynomials can be classified as other things as well. So you can classify by the number of terms. A monomial has 1 term, a binomial has 2 terms, and a trinomial has 3 terms. And each term is a monomial. Okay, so monomial and term are synonyms of each other. Okay, so the next part of this lesson is trying to determine, first off, is it a polynomial? And then what type of polynomial? Is it a monomial, binomial, trinomial? And anything more than 3 terms, we just use the generic term polynomial. It's just the whole thing. Okay, so here we go. Let's see. It says classify each expression as a monomial, binomial, trinomial, or not a polynomial. Okay, so we had some instances earlier where we talked about things would not be monomial. So if any one of the monomials within this is not a monomial, then the whole thing is not a polynomial. So if you look at A, x, y to the second. Okay, so first off, is this a monomial? Yes, it's a monomial. Do we have any terms with it put together by plus or minus? No, we don't, so this one is a monomial. Okay, B, okay, so this part right here, is it a monomial? Yes. Okay, over here, is this a monomial? Well, that negative exponent messes things up. So this whole thing, even though it looks really nice and pretty, is not a polynomial. Not a poly. Okay? Okay, so now if this negative wasn't there, okay, and it was just 2x squared minus 4y squared, then it would be something called a binomial. Because you've got a term here and a term here, then it would be a binomial. But because of that negative that we had right there, then it's not a polynomial at all. Okay, so C. So we look at this monomial. Is it good? Yes. Is this monomial good? Yes. Is this monomial good? Yes. So if that's the case, if those monomials are all good, okay, then we look at how many monomials do we have. We've got 1 put together with another one here with a plus, put together with a third one here with a minus. So this one is called a trinomial. Right. Now D, okay, this one, a squared plus b squared, are each one of those good? Yes, they are. And we've got this one here put together with the plus sign with this other one. So this one is a binomial. Sorry for the handwriting. Okay, so this first one was a monomial. The third one was a trinomial. The fourth one was a binomial. And B, because of this negative exponent, is not a polynomial. So what I'd like for you to do, I want you to pause the video and I want you to answer these by yourself. Okay, let's see how you did. Okay, so A, are each of these good? Yes. So this one is a good monomial, this one is a good monomial. There's 2 monomials put together with a plus sign, so this one is a binomial. Okay, B, okay, the 1.3x is good, but this 2.5, this exponent is not a whole number, so this one is not a polynomial. C, 6.3x squared, Okay, this one is good. Now the thing that confuses us is that this 6.3 here is not a whole number. The number in front does not have to be a whole number, it just has to be a number. Okay, so it's the exponent that has to be a whole number. So this one is a monomial. Okay. And then d, c to the 99th plus p to the third. You've got two terms there put together with a plus, so this one is a binomial. So again, a trinomial, the only one that we've seen here is this one right here, and it's three terms put together. Okay. So we understand how now to classify a polynomial as being a monomial, binomial, trinomial, or not a polynomial. You will have to do that on your assignment today. Now the last part of this lesson is how do I determine the degree of a polynomial? The degree is kind of the strength of the polynomial. And you've all played this game called King of the Hill. King of the Hill is where the strongest person tries to defend the hill. Right? And the strongest person is the one that kind of leads the group. Well, that's the same thing with a polynomial. It says the degree of a term is the sum of the exponents of the variables in the term. The degree of a polynomial is the same as the term with the greatest degree. Okay, so the first thing is we got to find out who's going to be king of the hill, or in this case, king of the polynomial, and you got to determine that based on the sum of the exponents of the variables in the term. Okay, so the exponents are going to be the sum on the variables. So if it's just a whole number, then we're not going to worry about that. Okay, it's going to have a degree of 0. Okay, so let's look. So we got this 4x squared is a term. Okay, so we've got 4 in this x squared part. That determines the degree of this monomial. And because that 2 right there, the exponent is a 2, this one is to the second degree. This one is to the 5th degree. But this one, how come it's to the second degree? Well, if you look at this, the exponent on the x is a 1. The exponent on the y is also a 1. So it says up here the degree of a term is the sum of the exponents of the variables. Okay, so since this x is a 1 and this y is a 1, it is a degree 2. And this 5 has no variables, thus it has no exponents on its variables, so it has a degree of 0. Okay, so now when we look at this entire polynomial, 4x squared plus 2x to the 5th plus xy plus 5, the degree of the entire polynomial is whichever monomial is the strongest, is the degree of the whole polynomial. So this one would be to the 5th degree. Okay, so let's see if we can do a couple of these, and then I'll have you do a couple. Okay, so this one says find the degree of each polynomial. So the first thing you do is find the degree of each monomial, and then that will then allow you to find the degree of the polynomial. So this one right here is an x. It has an exponent of 1, so this one's to the 1st degree. This 4 doesn't have any exponents on its variables because it has no variables, so it's to the power of 0. So what's the degree of the whole polynomial? 1. Okay, so it would be to the 1st degree. Okay, now this one here is a trinomial. Okay, so we look at this one. This exponent on this x is a 1, so this one's to the 1st degree. This exponent is a 2, so it's to the 2nd degree. This one doesn't have any exponents on its variables because it doesn't have a variable, so it's to the degree of 0. Okay, so who's the strongest? The strongest is 2, so this whole thing is to the 2nd degree. Okay, so what I'd like for you to do is pause the video and find the degree of each of these two polynomials. Okay, so let's see how you did. Okay, so A, you've got y again to the 1st degree, so it's going to be to the 1st. This 99 doesn't have a variable on its, it doesn't have a variable, so it doesn't have exponents on the variable, so it's to a 0. So this one is to the 1st degree. Okay, so this x is to the 1st. This x to the 4th is to the 4th, so that's 1st degree, this 4th degree, and this is 1st degree, so this whole thing would be the 4th degree. Okay? Now, the only thing that's really kind of difficult is whenever you have multiple variables put together, you kind of have to remember that. Okay, so if I gave you another one like 3 y to the 2nd, z to the 5th, this one is actually to the 7th degree because you got a 2, you got a 5, you add that together, you get 7. Okay, so let's kind of review this lesson real fast. It says determine whether each expression is a monomial. Okay, so 5, a to the 2nd, z to the 4th, is it a monomial? Yes. What about 3 to the square root of x? This one is a no because it's got an x underneath the radical. Now, classify each of these as being a monomial, binomial, trinomial, or not one. So this one is x squared, this one is x, this one doesn't have a letter, so this one is, and everything fits, so this one is a trinomial. Okay. 3m to the third plus 4m, both of those are good, so this is a binomial. Okay. Now find the degree of each polynomial. So here we got this 3a to the second is to the second power, or second degree. This a to the fifth is to the fifth degree. This 26 is to the 0th degree. Okay, so what's the degree of the whole thing? 5. Remember, you just take the one that's got the biggest. Okay, king of the hill. Okay, for 6, this one is to the third power, or third degree. This one's to the second power, so it's second degree. So what's the power of the whole polynomial? 3. Remember, you only take the strongest. You don't add them together. Okay. So what I want you to do on your assignment today, it's pretty simple. You're going to go to the Google form that's in the lesson that you see. And it says classify each expression as a monomial, binomial, trinomial, or not a polynomial. Okay. So on the Google form, you will have this. You will have the question, okay, and you're going to have 4 choices: monomial, binomial, trinomial, or not one. So you'll select the best answer for the appropriate thing. Okay. Then the rest of it, you're going to tell me the degree. Now on this form this time, all I want you to do is put a number. It's going to be a number from 0 to 7. Okay, so the highest degree that you'll have in this particular assignment is 7. Okay, and it's a drop-down menu, and you'll just pull the drop-down menu and select which one you think is the most appropriate. Okay, so what we've talked about today is polynomials. So hopefully you've learned a little bit about monomials, binomials, trinomials, and those are just 3 names for a polynomial. Okay, and you've also learned how to find the degree of a polynomial. So until next time, talk to you later.